All right, what is up, everybody? Getting into Unit 8 here. So this is with the geometric mean and similar right triangles. Now, geometric mean is not something that we use a whole lot the rest of the year, but it is something that you will possibly use when you get to like a pre-calc or a stats class, or like a micro or macroeconomics class when you get to college for business. Okay, so it's pretty easy to calculate. We're going to apply it to one triangle aspect, but just know it has a bigger, broader meaning when you get to a little bit higher level class. There's a different type of class, right? So growth rates, population growth, interest rates, right? So think of it's not necessarily like the mean, right, or the average, because remember, to find average, you're adding and then dividing. For geometric mean, there's going to be a little bit different process, but it's kind of like finding the middle, but in a different aspect, right? So the main thing to understand is it's kind of like you're finding something that is going to be growing at a certain rate, and that's what geometric mean comes into play. For us, we're just going to be using it to find the altitude of right triangles, okay? And so we find geometric mean by taking the square root of the product of two numbers. So product is now multiplication. That's how it is different from an average or just your normal mean, because that is when you just be adding, okay? So to find the geometric mean, it's the square root of the product of two numbers. So let's say I have my first number is A and my second number is B, right? So to find my geometric mean, I would first need to multiply those numbers together, and then I would take the square root of them. So my geometric mean is A times B, and then I take the square root of that value. So X would equal my geometric mean, okay? And so, like I said, it's a pretty simple process. There's not a whole lot to it. The one thing that is important is depending on how I want your answers, right? Like if I want your answers as a decimal, you can just use your calculator and take the square root. But if I ask you to leave your answer as a simplified radical, that kind of comes back to stuff we did in first semester when we were revisiting factor treeing from Algebra 1. So let's take 5 and 20. So my first thing I would do is I would multiply 5 times 20. That gets me 100, and then I'm taking the square root of that number, so my geometric mean is 10. So notice, right, that the geometric mean is not something that's directly in the middle, right? Like the average of 5 and 20, so if I did 20 plus 5 is 25, 25 divided by 2, that's 12.5. So 12.5 is directly in the middle between 5 and 20. Compared to geometric mean, the value is 10, okay? And so try not to get mean or average confused with geometric mean, because they're not the same thing. Let's do another one, 36 and 4. So first step, 36 times 4. 36 times 4 is 144. The square root of 144 gives us our geometric mean, which is 12. And that one's very obvious to see that it's definitely not between or in the middle between 4 and 36, right? And let's do one more using 40 and 15. So 40 times 15 is 600. So we need the square root of 600. Now 600, if I did that in my calculator, the square root of it, it's 24.5, right? But let's say I want to leave this as a simplified radical. So what's the largest perfect square that goes into 600? Remember, perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, going on. So hopefully what you thought of was 100, because 100 times 6 is 600. And then the square root of 100 simplifies to 10. And then once we pull that out of the radical and we have no perfect squares that can go into 6, our geometric mean is 10 rad 6. And then we would be done. So the first part of the homework tonight is just going to be using geometric mean, or finding the geometric mean between two numbers. Okay? Pretty straightforward, pretty simple. Now, before we get into how we use it with triangles, we're first going to look at what type of diagram using triangles that we can use a geometric mean. So, and that has to deal with similar right triangles. So remember, similarity, that's when we were using our proportions to create, we were using ratios to create proportions, we were cross multiplying. We're not going to do that here. Okay, I'm going to simplify this process for you. So imagine you have a right triangle. Okay, triangle ABC. And then we're going to draw an altitude of this triangle from the hypotenuse. So our hypotenuse of our triangle is side AC, and an altitude has to be perpendicular to a side. In this case, it's going to be perpendicular to a hypotenuse, and it has to travel to the opposite vertex. In this case, the vertex opposite is B. Okay? So let's draw the altitude of the triangle from the hypotenuse. And that would look something like this. Okay, so now I have point D. D is where the altitude is meeting the hypotenuse. So now what happens is, when I draw this altitude in, I'm creating two more triangles for a total of 3 triangles. Triangle 1 is our original big triangle. Triangle 2 is this medium-sized one. And then triangle 3 is the smaller one right here. So we have a total of 3 triangles, and notice that all 3 triangles are right. That's important. And the reason it's important is because all 3 triangles are similar. So they are all proportional to each other. Okay? And now eventually we're going to be using geometric mean to find the altitude right here. But it's important to be able to look at this and to be able to identify and create the similarity statements for these triangles. So let's go ahead and do that. So I have triangle ABC. That's our original big triangle. Now the key to doing this is noticing that each right triangle has hypotenuse, it has a longer leg, and it has a shorter leg. So for us, our hypotenuse is AC, our longer leg is BC, and our shorter leg is AB. So now let's look at this triangle here, our medium-sized one. Which side is the hypotenuse? Side BC. Which side is the longer leg? Side DC. And the shorter leg is then BD. So what I'm going to do is I'm going to draw the medium-sized triangle with the same orientation as our original big triangle. So I have my short leg, my long leg, and I have my hypotenuse. Once I do that, it makes it really easy to figure out what sides are corresponding, right? So AB is how I started my first one, which means I'm going to start my second one with DB. Okay? Followed by BC, followed by BC. Actually, you know what? I drew that incorrect. Oh my gosh. It should be, my fault, guys. It should be BDC. My apologies. So when I draw this out, or when I write this out, it should be BDC. Whew, almost made a mistake. Now, the reason I was able to catch that is because I noticed that my right angle for my medium triangle was D, and my right angle for my medium triangle is B. So notice how it's in the middle here. So remember, our angles have to be, corresponding angles are congruent. Okay, whew, almost made a mistake. Good catch. Okay, so it goes short leg, long leg, hypotenuse. Short leg, long leg, hypotenuse. So now for our smaller triangle, let's see if I did this right. Hopefully I didn't make a mistake again. It would be short leg, long leg hypotenuse. And notice that the right angle in our smaller one is still D. So D should be in the middle, and it looks like I messed it up again. Let's just go ahead and erase this right here. So again, this should be D, this would be A, and this would be B right here. Okay, our short leg is AD, our longer leg is DB, and our hypotenuse is AB. So our order would be A, D, B. Okay. And so the key is matching up the short and the long legs of the right triangles. Obviously I didn't do that. It's late on a Thursday, so hopefully you guys can forgive me. The way that you see it right now, though, is correct. Okay. Go ahead and pause the video. See if you can write out this similarity statement for all three. Okay. So I went ahead and drew out the first one, and then notice I put the orientation of all of them the same. And then what I'm going to do is I'm going to label the right angle for my other two. So I know the right angle of my medium-sized triangle is Z, and the right angle for my small triangle is also Z. So for my first triangle, I started out with the small leg WX, so the small leg of my medium-sized triangle is XZ. And notice my right angle is in the middle, so my Z has to go in the middle here, so X to Z to Y. For my small triangle, WZ is my small leg, so I'm going to start this with W. Sorry, I should have filled this in. And then WZ to X. And again, all of these triangles are similar. So when you draw the altitude from the hypotenuse of a right triangle to the right angle, you're creating three similar triangles. Okay? So second part of the homework today is going to be doing something like this. And our third part of the homework is using the geometric mean to find the altitude of a triangle. So what you'll see is I'm going to put the exact same type of diagram up on the board or on the screen. So I have triangle ABC, and notice I'm going to draw in the altitude. So the altitude is X. And now I've given the two lengths that the hypotenuse is being cut up into, 5 and 20. Okay? And now X is going to equal the geometric mean of the cut up hypotenuse lengths. So in this case, 5 and 20. So if I want to solve that out, X equals 5 times 20, and I got to take the square root of that. So in this case, X equals the square root of 100, so X equals 10. So now that I know X equals 10, remember these are three right triangles. So what I can do now to solve for Y and Z is I can use Pythagorean theorem. So I'm going to use Pythagorean theorem on my small triangle. I'm going to use Pythagorean theorem on my medium-sized triangle to find those missing lengths. So 5 squared plus 10 squared equals Y squared. Remember, Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. For my medium triangle, it's 10 squared plus 20 squared equals Z squared. 25 plus 100 equals Y squared, so 125 equals Y squared. Let's just, for the sake of time, get our answer as a decimal. So I'm going to take the square root of that. Square root of 125 is 11.2. So Y's length is 11.2. 100 plus 20 squared is 400. So 500 equals Z squared. Take the square root. Square root of 500 is 22.4. So again, guys, I'm not simplifying the radical there. I'm just doing Pythagorean theorem and then using my calculator to find the square root decimal value. Okay. And so, guys, we're really only going to focus on problems like this where we only have to use the geometric mean one time, and then we can use Pythagorean theorem after that. Go ahead and pause it, see if you can do this one on your own, and then I'll show you the setup. So A is the geometric mean of 24 and 6. So 24 times 6 is 144, so A equals the square root of 144. 144 is a perfect square, so A equals 12. Once I know A equals 12, I'm going to use Pythagorean theorem to solve for my other sides. 12 squared plus 24 squared equals B squared. And then my other equation would be 12 squared plus 6 squared equals C squared. 144 plus 24 squared is 576. 576 plus 144 is 720. Square root of 720 is 26.8. So B equals 26.8. 144 plus 36 equals C squared. 144 plus 36 is 180. So 180 equals C squared. Square rooting this. So the square root of 180 is 13.4. So that's how we can use geometric mean to find the altitude from the hypotenuse. And then from there, we can use Pythagorean theorem to find the missing lengths. Good luck. Let me know any questions.